Bismillahirrahmanirrahim. Start with the greatest name of Allah Almighty, most gracious and merciful, whose blessings are uncountable, whose mercy is unlimited, whose love is our life, and whose worship is our faith. First, let me introduce myself. I am Mohammad Salman Malik from BSCS, Sindh University campus, Larkana. As we all know, because of lockdown, universities are still closed and decided to take online exam. So I am here for it. Let's move on to outline. So here's outline. What is data structure? What is garbage collection? What is graph? And what is tree traversal? So my first topic is what is data structure? The simplest data structure is the one-dimensional linear array, in which stored elements are numbered with consecutive integers and contents are accessed by these numbers. Data items stored non-consecutively in memory may be linked by pointers. Memory addresses stored with items to indicate where the next item or items in the structure are located. Many algorithms have been developed for sorting data efficiently. These apply to structure residing in main memory and also to structure that constitute information system and database. More complex data structures may incorporate elements of simpler data structures. So data structure is used in these things. Data structure used in sorting, linked list, spanning tree, hashing, stack, graph, tree. So I am going to expand some more example and tell you in simpler way, in simple form, that what is data structure. Data structure, we can say, is a set of rules to store, to give a proper way, to give a map, to give a structure of our data, and to summarize it, and to analyze, and we can summarize it in a good way, in a proper way. Like I'm giving you an example that in dictionary the words are in sequence. First of all, if we are finding a word, for example, spanning. So first of all, we will check S, and we will start from S. First of all, we'll check in the index where is the S, and we will take the number of the page and start from searching it. So if there would not be the sequence of these words, so how could we find it? Our time, it consumes a lot of times to find. So data structure, I can say that it is very important in computer science. It helps to understanding and implementations of programming language. It helps to make, again I will say, a proper map and give a structure. Uh, so I am going towards a second topic. What is garbage collection? In computer science, garbage collection is a type of memory management. It automatically cleans up unused objects and pointers in memory, allowing the resources to be used again. Some programming languages have built-in garbage collection, while others require custom functions to manage unused memory. Garbage collection may also be done at compile time, when a program's source code is compiled into an executable program. In this method, the compiler determines which resources and memory will never be accessed after a certain time. It can then add instructions to automatically deallocate those resources from memory. While this is an effective way to eliminate unused objects, must be undone. It must be done conservatively to avoid deleting references required by the program. Garbage collection. Uh, Here is an example, and I will also define it in a more simple word. Uh, Tag memory cells which are currently in use, and empty space is collected onto the storage list. So here is an example: new cars. Just after garbage collection, discarded memory, and here is a new free memory. And or garbage collection, what it does, the cars and the useful data. It separates the useful data and which are the unused data and unused folders like free folders and other things which we do not used and which are not in use of our computer, and these are the catchy or some these extra things. It makes it in free memory. And here is the new working memory. My third topic is graph. A graph is a common data structure that consists of a finite set of nodes or vertices and a set of edges connecting them. A pair xy is referred to as an edge, which communicates that the x vertex connects to the y vertex. In the examples below, circle represents vertices while these represent edges. The simple definition of graph is a pictorial representation of set of objects is called graph. Here are the types of graph. Simple graph. A simple graph is a graph which does not contains more than one edge between the pair of vertices. A simple railway track connecting different cities is an example of simple graph. So here is a definition of simple graph and also example. I've used another example here. This is also a graph. It is moving straightly and it does not connecting two vertices. Like here, a simple railway tracks connecting different cities is an example of simple graph. It is so straight, it is going straight, and it is a example of simple graph. Multigraph. Any graph which contains some parallel edges but doesn't contain any self loop is called multigraph. For example, a road map. What is parallel edges? I will define it in second. First of all, I am telling you the multigraph. What is multigraph? These are the parallel edges. Here you can see uh, vertices, two edges from two vertices. These are connecting them, and parallel edges. If two vertices are connected with more than one edge, then such edges are called parallel edges. That is, many routes but one destination. So here is the example that I was telling. Two vertices and two edges connecting both to them means two edges and two vertices. Loop. An edge of a graph which join a vertex to itself is called a loop or a self loop. So here is our loop. This is called loop. Null graph. A graph of order n and size 0, that is graph which contain n number of vertices but do not contain any edge. So we have three vertices here, A, B and C, but we do not have any edge connecting the vertices. Complete graph. A simple graph with n vertices is called a complete graph if the degree of each vertices is n minus 1, that is, one vertex is attached with n minus 1 edges. A complete graph is also called full graph. Complete graph means all edges and vertices are connected. None is remaining. So for example, A and B are connected and B and C are connected, but A and C are not completed, so it means it is not a complete graph. So here is our another topic. What is tree traversal? Traversal is a process to visit all the nodes of a tree and may print their values too. Because all nodes are connected via edges, links, we always start from the root head node. That is, we cannot randomly access a node in a tree. There are three ways which we use to traverse a tree: in-order traversal, pre-order traversal, post-order traversal. Generally, we traverse a tree to search or locate a given item or key in the tree, or to print all the values it contains. In order traverse all this traversal method, the left subtree is visited first, then the root, and later the right subtree. We should always remember that every node may represent a subtree itself. If a binary tree is traversed in order, the output will produce sorted key values in an ascending order. So first of all, we visit L means left, N means node, R means right. We start from D, and following in order traversal we move to its node subtree B. We start from here and move here, B. And B is also traversed in order. The process goes on until all the nodes are visited. The output of in-order traversal of this tree will be. So here is the output, and I am giving you a trick. I am telling you a trick to solve in-order traverse. So we will start from L, N, then R. Means L means left, R means right, and N means node. So we start from here. L, here is a D, and then we move to N. L and R. N, B, and then R. R means we go move to then E. Okay. So again we started from here and then we move towards here. It comes E, A. Then again to left L, then N, C, and then right G. Pre-order. Pre-order traverse all in this traversal method. The root node is visited first, then the left subtree, and finally the right subtree. NLR. N means node, L means left, R means right. We start from A. We start from here, node. We start from A and following pre-order traversal, we start visit A itself and then move to its left subtree B, N, then L. Then again move to the left D and then E. Then we will move A, node, N, then L we are finding here B, and then again we move to left, it means D, and then we goes to right, N, L, R. The process goes on until all the nodes are visited. The output of pre-ordered traversal of this tree will be, so here is the output, and again we will use the trick I have told you before, NLR. N is here A. So here you can see the output of this pre-order is first coming A. Then the second number would come B, and then D, then E, and then we goes to right. And here comes N, means C. Then L comes F, and right G, post order. Post-order traverse all n this traversal method. The root node is visited last, hence the name. First we traverse the left subtree, then the right subtree, and finally the root node, LRN. Same trick is used, LRN. We start from D, and following post-order traversal we first visit D, then move to its right subtree F. Okay. And then we move to subtree B. The process goes on until all the nodes are visited. The output of post-order traversal of this tree will be D, L, then E, right, L, R, then N. N is B. So then again we goes to left of right subtree, then G, then C, and in last A. Thank you. I hope whoever are watching this video, I hope they would love, and especially my teacher, so he could give me good marks. So remember me in your prayers. Stay blessed. Khuda Hafiz.